All right, so draw a picture in case it doesn't make sense. But basically, it's saying that if you have a function and you plug something in and it gives you two different things, it violates a definition. Okay. Function can be anything. Could have some set. Say a relation between people and phone numbers, right? So you can have, I don't know, Mike and John. Let's say James, Larry, whatever. This would be one set right here. And let's say they all should have at least have one phone number, right? So the relation between these two is each person has a phone number. So we'll make up some numbers. Doesn't matter. Just an example. I don't recommend calling these numbers. Okay. Last one. Yeah, the numbers don't matter. So if there's a relationship between each person having one number, that is in fact a function. So the relation between this guy and that guy, so that's one phone number. Let's say John has this phone number. James has that phone number. And Larry has this guy. So if every input has exactly one output, then it is a function. But let's say, I don't know, let's say Larry had two numbers, right? Maybe he has some secret girlfriends or something. And this is no longer a function. This is a function. In mathematics, we'll have basic examples like this, where we have some numbers. Yeah, numbers 2, 3, 5, 7. And you have some outputs. So let's say the relation between these two sets is a function. This is my x domain. So that's the domain is where the x's live. Y is the outputs. H. Inputs, outputs. So if the function, let's say it does something specific. Let's say this function doubles your number and adds 5. So if I plug in 1, it would double it and then add 5. So 1 times 2 is 5 should be mapped to 7. Does that make sense? So 2 would be what? 2 times 2 is 4. That's 5. That would 9. 5 would 18. 7 would 7 times 2 is 14. It's 5. So this is a function because every single x value only went to one specific. So let's find some examples. Is the following a function? Okay, so here's a set of points. Let's make one up. We have 1, 2, 5, 7, 3, 4, 1, 10. It's just a function. So going to the definition, right, we said every x value should only have one y value. But what is the 1 doing, right? 1 is going to 2, and later it goes to 10. So this is Larry. This is a problem. It's not a function. You see why that is not a function? Since the x value, x equal to 1, is outputting, or you could say assigned to, assigned to 2 and 10. This violates that this is not a function by definition. So whenever you do questions like this, if they give you a set of points or a table of x's and y's, just check the x values and see if they go to two different places. And if they do, you say not a function. If they don't, then you're good. So it is a function. Most of your, well, the first like 4 questions will be something like that. They give you just some values and you just gotta say yes or no. Okay. Later they're gonna say determine whether the following equation defines y as a function of x. We give you a function. The easiest way to find out if this is a function is to just graph it. So let's do that. Let's find a graph. Or punch that into your graphic calculator if you have it. Okay, so this will be y equal to square root of x minus 6. All right, so way you can tell is if you were to draw a vertical line through every single piece of the graph, then you will see it will only touch one time. Since that happens, it will be a function. Okay. I know it looks like it could touch twice there, but it's not going to. You can do it. If a vertical line were to hit twice, then that means there's an x value that goes to two different places, but that's not going to happen. You plug in 6, right? You would get 0. It's not anything else. So back to using the vertical line test. Graph is a function does draw vertical lines on our graph, then they touch the graph. Draw it. So let's x equals to 6. You get 0, so 2, 6 starts here. So two times. So it is a function. Does the vertical line test make sense? So the domain is a set of all inputs, all the x values. Some questions will begin to ask you to state the domain of the given function. So we're going to give you a function and you have to figure out, okay, where exactly is the domain values? So pretty much for any line, this is a line equation, right? For any line, the domain is going to be everything because it just keeps going, unless it's a vertical or horizontal line, then things are a little bit different. Right, so let's use 6. In the wrong buttons. 7. So we know that's a line, but what does domain mean, right? So basically, whenever you do domain, you want to ask yourself, is there an x that I'm not able to plug in here? Is there an x that causes problems, like division by 0, negative something weird? But there is no x that will cause problems. You see it visually. I can pick any x forever, and it'll eventually just hit the wall. Doesn't matter. Okay. So every single number actually hit some point on it. So for all lines with a finite non-zero slope, finite slope domain is negative infinity to infinity. Visually, this is what's happening. If every single x eventually hit the graph negative or see what I'm saying? That's the reason. Determine the domain of the following, of the function, I guess. I'll choose something simple. Let's make a couple of parts. F of x equal to the square root of x plus 4. So whenever you're asked about domain, you have to stop and think, is there an x that I can't use? Right. We know that they cannot be negative in here, correct? So one easy way you can try to figure this out is say, you know what? I know that the inside must be greater or equal to 0. It's okay if it's 0, so equal to. So I'll solve for x, and that will give me the domain by subtracting 4 over. And I believe we talked about this interval would be negative 4 all the way till infinity, right? So that arrow means visually negative 4 all the way forever. That's right. So this would be your domain. So as long as I choose something in here, I'll be fine. Because if I plug in negative 5 or anything below negative 4, the inside becomes a negative. I can't use it. So let's start with trying to figure out what is not allowed. Okay. And if everything is allowed, then the domain's everything. So do you see a potential problem? An x value that is not allowed. So again, negative 6 at the bottom, division by 0. So right away you should see x cannot be negative 6. Anything else is fine. So I have to create your interval. Okay. That's right. This guy. So if you can't write the interval, figure it out. I recommend drawing it out visually. Say, okay, this means anything. It's fine except -6. Can't use it. So everything after is fine. Everything before is cool. So if I write this using my inequalities, so I can say for this section, x must be greater than -6. So here, x must be less than -6. So just separate it into two intervals. The domain will be this first part. It's always the smallest or most negative first. So it keeps going down forever. So negative infinity up until biggest value, -6. Then have a second part. Everything after -6 is fine. So starting at -6 or starting right after, everything above. So you just union these two sets of intervals. Okay. So drawing this out should help. First thing is identify what is an x that doesn't work, if it exists, and then visually graph that on a line graph. Then just create your intervals.
How did we find between A and B that in A, the greater sign was greater or equal to, and on B, it's not equal to? Like, what's the difference between?
Oh, you mean up here?
Yeah.
Yeah, so it's equal to because you're allowed to use it. Plug in -4. -4 plus 4 gives you a 0, which is okay. You are allowed to square root of 0. Here, you're not allowed to use -6, because if you do, you division by 0. So I have to exclude it. So I do not include it. So I do not put it. See that?
Okay.
So when you don't include it, don't put brackets. Do not put it. Then the homework will ask you, like, does that have brackets or does it not? You'll be able to figure out. Bottom x plus 3 on top. Okay. Right, so before you start this guy, you gotta factor the bottom. So this is the difference of squares, correct? Your factor section. So this will tell you x cannot be. If you're not able to figure it out by looking at it, I suggest, I didn't do it up here. Maybe we should have said that x plus 6 cannot be 0. Solve for x, right? See what I mean? That here too, you can say, you know what? I know the bottom can't be 0, so solve for it and find out exactly those values are. So move the 4 over. Square root both sides. Get x equal to plus or minus 2. So x cannot be 2 or -2, which might have been clear at this point. If I plug in a 2 or a -2, I get issues. So the domain will be determined by the restrictions. So the domain is everything except these two numbers. Okay, so this is saying right here. So visually, we have a -2 with a hole in it, 0 there, I guess. 2 with a hole in it. So everything after is fine. Everything in between is fine. Everything before is fine. So we have 3 different sections. So we need to write the intervals. I'm not including 2, so I have to put parentheses. Everything after 2, so 2 to infinity, right? Everything between -2 and 2 do not include the endpoints, so no brackets. All the way down to -infinity up until -2. So we have 3 sections because we have 2 different two holes, basically. 2 holes that are under. So then you just write it in as a union of these 3 sets, or 3 intervals. So from here to here, union with here to here, union with there. That's it. Any questions on this problem? In the homework, they might write or instead of union, so I'm going to write that note right here. Just know that that means the same thing. Okay, so given a function f of x equal to 2x plus, I don't know, 3. F of 0 means you plug in a 0 for all your x's. So that would be equal to 0 plus 3, which is 3. So that means that f of 0 is equal to 3, which is the same as writing the point 0, 3. That's what all this notation means, because if you're not used to the notation, it's weird. Okay, does that make sense? Here's your function. Plug in an x, so I write it here. So wherever you have an x, go ahead and plug it in, do your math. 2 times 0, 0, plus 3 is 3. So f of 0 is equal to 3. So this is saying, look at the function gives me 3 and 0, which gives me a point 0, 3. Okay. So just don't let this notation bother you. If I plug in a w, that means you plug in a w. Right? If I plug in triangle, plug in x plus h, that means plug in x plus h, which would be 2x plus 2h plus 3. But you see what the notation is saying. Don't let it mess with you. They tell you f of something, just plug it in. Wherever there's an x. If there's a bunch of x's, plug it into all. I think this would be the hardest part of the section. Find the difference quotient of f of x equal to 3x plus 2. The difference quotient is this guy, so f of x plus h minus f of x over h. So I recommend doing this in steps. Step 1, find f of x plus h. So plug in x plus h and see what happens. That would be 3 times x plus h plus 2, which is a 3x plus 3h plus 2. That's all there is to it. Step 2, find f of x plus h minus f of x. So put it together. That's what I'm saying. So we just found this guy. So plug that in here. Then minus the entire f function, which is the original. 3x plus 2. To subtract them, that would be 3x plus 3h plus 2. So I'm left with 3h. Everything else cancels. Step 3, divide by h. So take the result and divide by h, and you get 3. So 3 is the difference quotient of this function. Does that seem okay? Step 1. Find f of x plus h. This is the hardest part for this procedure. So x plus h. Let's see what happens. So to this x squared, which means I'm going to have to FOIL this. So give us x squared plus 2xh plus h squared minus 5. From here to here, I applied the formula, but you can also do this if you want to. Just multiply it out. It's your call. Once you do, you'll receive these 3. Step 2. Find the difference x plus h f of x. So as we just found, so all you're going to do is subtract the f from 2. So here we go. Squared plus 2xh plus h squared minus 5 minus the original, which is up top. So everything should cancel except stuff that has an h on it. It's usually how it goes. So switch your signs and start canceling. So the x's will be gone, squares, and the pi's will be gone. will only be left with xh plus h squared. Step 3, divide by h. So you take your result, divide by h. Factoring, cancel out. This will be difference quotient here. All right, I don't want to get too far into chapter 3 because I want you to start focusing on test 1 stuff. So I'm going to stop here. You guys have any questions from your homework or stuff you're struggling with? That's going to be on test 1. If you feel like you're comfortable, you're welcome to head out. But if you're not, I'd like you to stay and ask some questions.